There is a planet in our solar system where the sun can rise over the same pole for decades. A world almost 4 times wider than Earth, surrounded by dark rings, swept by powerful winds, and tilted so dramatically that it appears to roll around the sun. At first glance, Uranus looks almost dead. Cold, distant, quiet. But that appearance is one of the biggest traps in planetary science, because beneath those pale clouds is a world that doesn't behave the way we expected. Its seasons are extreme. Its atmosphere is active despite receiving very little sunlight. Its magnetic field is unlike anything around Earth. And the only spacecraft ever to visit it may have arrived on one of the strangest days Uranus has ever experienced. The deeper we look, the less Uranus resembles a frozen, finished world, and the more it looks like a planet we have barely begun to understand. Uranus is the 7th planet from the Sun, orbiting at an average distance of roughly 2.8 billion kilometers. At that distance, sunlight is already weak, but Uranus has another problem. Its rotation axis is tilted about 97.77 degrees relative to its orbit. In practical terms, Uranus is almost lying on its side, and that creates some of the most extreme seasons in the solar system. Uranus takes about 84 Earth years to complete one orbit. For roughly a quarter of that journey, one pole can face the sun while the opposite hemisphere remains in darkness. That darkness can last around 21 years. Imagine a winter that lasts longer than an entire human generation. Then imagine the opposite pole receiving continuous sunlight for roughly the same period. It sounds almost impossible. But this is simply the geometry of Uranus, and that geometry creates our first mystery. A planet receiving so little sunlight should be easy to imagine as a quiet, frozen world. But Uranus refuses to cooperate. Voyager 2 reached Uranus on January 24, 1986. It had taken the spacecraft more than 9 years to get there. And because Voyager was flying past rather than entering orbit, the encounter was brutally brief. NASA's spacecraft had only about 6 hours for its close study of the Uranian system. That was enough to transform our understanding of the planet, but not enough to solve its mysteries. Voyager saw winds, clouds, atmospheric structure, and evidence of active weather. Uranus can be extremely cold, with a mean temperature around 60 kelvins, roughly minus 213 degrees Celsius. Yet cold does not mean still. The atmosphere moves, storms appear, cloud features evolve. And Uranus presents a particularly strange energy problem. The planet receives only a tiny fraction of the sunlight Earth gets. So where does that activity come from? For years, Uranus was famous for apparently emitting very little excess internal heat compared with Neptune. But recent research is complicating that picture. Evidence from observations across Uranus's long seasonal cycle suggests that the planet does have measurable internal heat and is continuing to cool. So the mystery becomes even more interesting. Not simply, why is Uranus so cold? But how does a planet this cold remain so active? That question leads directly beneath the clouds. And that's where Uranus gets stranger. Earth's magnetic field is broadly organized around the planet's rotation axis. Uranus is different. When Voyager 2 measured its magnetic environment, scientists discovered that Uranus's magnetic field was dramatically tilted and significantly offset from the planet's center. Its field is not a neat dipole aligned with the planet. Instead, it creates a magnetosphere with an extraordinarily complicated geometry. The magnetic tail behind Uranus is twisted by the planet's rotation into a corkscrew-like structure. From a distance, Uranus looks almost featureless. Up close, its invisible environment is anything but simple, but there is an even bigger problem. What if Voyager's strange measurements weren't showing us the normal Uranus? For decades, scientists used Voyager 2's 1986 measurements as the foundation for understanding the Uranian magnetosphere. That made sense. It was our only close encounter. There was just one problem. Uranus doesn't sit in isolation. The sun constantly blows a stream of charged particles into space, the solar wind. And during Voyager 2's encounter with Uranus, the spacecraft may have encountered unusually intense solar wind conditions. A 2024 study re-examined the old data and suggested that the magnetosphere Voyager encountered may have been unusually compressed by that solar wind. That means some of the extreme properties we attributed to Uranus may have been influenced by the environment surrounding the planet at that exact moment. Think about what that means. We have spent decades trying to understand Uranus from a single close encounter. And that encounter may have captured the planet during an unusually abnormal state. The first photograph of Uranus may not have been a portrait of the normal planet. It may have been a snapshot of Uranus under pressure. And suddenly, an old mystery becomes a new one. What does Uranus actually look like when the sun isn't interfering? We don't know. Not yet. Uranus has rings. 13 known rings form a narrow, dark system around the planet. They are nothing like Saturn's enormous, bright architecture. Most of Uranus's rings are narrow and difficult to see. When Voyager photographed them, they revealed a system of sharp, delicate structures unlike the broad disks we associate with Saturn. And the rings aren't alone. Uranus has a family of moons moving through this strange environment. Today, NASA lists 28 known moons around Uranus. And some of the most interesting aren't simply rocks orbiting a dead planet. They may be worlds with hidden interiors. The 5 major moons look frozen from the outside, but Voyager's images revealed something unexpected. Their surfaces are geologically complex. Miranda, in particular, looked almost chaotic. Cliffs, grooves, terrains that suggested a complicated geological history. The question is, what could have powered that activity? One possibility is that some of these moons may have retained enough internal energy to sustain subsurface liquid water. Another possibility is tidal interaction and past orbital evolution. Scientists do not yet know which explanation dominates, and we have not confirmed oceans beneath these moons. They remain candidates. But if some Uranian moons really do contain subsurface oceans, the Uranian system becomes something much more interesting than a collection of frozen worlds. It becomes a laboratory for studying how hidden oceans might survive far from the sun. To understand why scientists are so interested in Uranus, we have to look beyond it. The planet belongs to a class called the ice giants. Uranus and Neptune are fundamentally different from Jupiter and Saturn. And this matters because ice giants may be extraordinarily common beyond our solar system. Astronomers have discovered many exoplanets in size ranges comparable to Uranus and Neptune. Yet in our own solar system, the ice giants remain remarkably poorly explored. Voyager passed Uranus once, and that is essentially the entire close-up record. One spacecraft, one flyby, a few hours. For a planet that may represent one of the most common kinds of worlds in the galaxy, that's an astonishingly small amount of information. Which is why the next step is no longer simply another telescope image. It is an orbiter and a probe. The National Academy's 2023 to 2032 Planetary Science Decadal Survey ranked a Uranus orbiter and probe as its highest priority new flagship mission. The proposed spacecraft would spend years studying the planet rather than hours. It would investigate Uranus's atmosphere and interior, its magnetic environment, its rings, its moons, and it would send an atmospheric probe down into the planet itself. That is the difference between looking at Uranus and actually interrogating it. A long-term mission could finally tell us how the planet's magnetic field is generated. It could measure the atmosphere directly. It could investigate the structure of the interior, and it could examine the major moons closely enough to determine whether any really are ocean worlds. The stakes go far beyond one strange blue planet. If we understand Uranus, we gain a better model for an entire class of planets, worlds that may be everywhere. Uranus is often described as the oddball of the solar system, the planet tilted on its side, the cold blue giant, the world with dark rings and strange seasons. But that description misses the deeper story. Uranus isn't fascinating because it is weird. It is fascinating because almost every strange thing about it points toward a deeper question. Why is it tilted so dramatically? How does its atmosphere remain active? How much heat is actually coming from its interior? Why is its magnetic field so unusual? What did Voyager really see in 1986? And what is happening beneath the surfaces of its moons? The most dramatic possibility is not that Uranus is hiding some impossible phenomenon. It is that the planet is hiding something much more valuable, a missing piece of how planets work. Because when we finally understand why Uranus became what it is, we may also understand something about the countless ice giants orbiting other stars. And perhaps that is the real secret of this frozen world. From billions of kilometers away, Uranus looks like a pale, silent sphere disappearing into darkness. But the closer we get, the more we realize that almost nothing about it is simple. Remember the planet we imagined at the beginning? Cold, silent, almost dead. That image was never quite true. The darkness around Uranus hides motion. Its cold hides energy. Its smooth clouds hide violent weather. Its magnetic field hides a structure we still don't fully understand. And its moons may hide oceans. The strangest thing about Uranus may be that after everything Voyager taught us, we still haven't actually seen the whole planet. Not even close. The next spacecraft won't simply visit Uranus. It may finally reveal what Uranus has been hiding from us for 4 decades. And when it does, the frozen giant may turn out to be one of the most revealing worlds in the entire solar system. Some planets invite us to explore them. Uranus first asks us to understand why it exists this way. The universe has more stories to tell. See you in the next one.